Games never pause. Ever. It doesn't matter whether the game is single-player or multiplayer, whether you hit the escape button or the pause button. Pausing and freezing everything in a video game is simply too hard. Let's use the game God of War as our example. So you're in the middle of a brutal fight. Kratos is swinging his axe mid-air. You pause the game. The scene freezes instantly. It looks like time has stopped, but in reality, that stillness is carefully simulated. Let's start with the foundation. At the core of every video game is something called the game loop. From the moment you launch God of War until you close it, this loop runs continuously. It repeats itself dozens or even hundreds of times per second. Most modern games aim for 60 frames per second, which means this loop is executing 60 times every second. Each time it runs, it follows the same cycle. First, it checks for input. Did the player press a button or move the joystick? Then it updates the game world. This includes physics, character positions, enemy AI, animation states, and more. Finally, it renders a new frame to the screen, so it reads input, updates, and renders. Then it does it again and again. Now, when you hit pause in God of War, this loop doesn't actually stop. If it did, the entire game would crash. Instead, the game loop keeps running. What changes is how the systems inside the game respond to that loop. Just like games, great design responds to every input. So, today's video is brought to you by Mobbin, the ultimate design inspiration platform for creators like you. Imagine having access to over 500,000 real-world app screens and 80,000 user flows from 1,200 industry-leading apps all at your fingertips. That's Mobbin, and I have a 20% discount for it just for you. Forget sifting through conceptual designs or manually taking screenshots for hours. Mobbin empowers you to find highly relevant design references in seconds. Whether you're benchmarking competitors, researching UI patterns, or staying up to date with the latest trends, Mobbin has you covered. With powerful features like NLP search, visual search, and text in screenshot search, you can find exactly what you need when you need it. And with their Figma plugin, you can export screens directly into your workspace. From freelancers to enterprise teams, Mobbin offers plans to suit every need. Join over 870,000 designers worldwide who are using Mobbin to create great digital experiences faster and smarter. Check out Mobbin today and elevate your design game. Links in the description below. Now, let's walk through what happens when you press the Options button to pause. During that frame, the input system detects your button press. It passes the command to a part of the engine called the State Manager. This is responsible for changing the state of the game from playing to paused. But even though the state changes, the game loop keeps running. What really happens is that many of the game's systems begin checking whether they should keep updating or freeze temporarily. This conditional behavior is what gives the illusion of a full pause. One of the most important systems affected is the Time Manager. This system is responsible for tracking the passage of time between each frame. It calculates what developers call delta time, or delta t, which is usually around 16 milliseconds per frame if the game is running at 60 frames per second. Delta time controls how far things move in a given frame. Let's say Kratos is running forward. The engine calculates his new position by taking his current position, adding his velocity, and multiplying that by delta time. So the formula looks like this. New position equals current position plus the result of velocity multiplied by delta time. Now, if the Time Manager reports that delta time is 0, then that movement calculation becomes 0. And the result? Kratos stays exactly where he is. That's the trick. The engine keeps doing all the math, but it uses delta time to simulate stillness. So why not just stop everything completely? Why not halt the entire program? That approach doesn't work well with modern games. God of War, like many modern titles, is built using multi-threading. This means the game is doing multiple things at once. They split their tasks across many threads, running in parallel, often on different CPU cores. And when you press pause, not every thread can freeze in the same way. Some systems need to keep going quietly in the background, others need to pause instantly, and a few need to wait for the right moment before they can safely stop. The graphics thread is a good place to start. The GPU does not know what a pause is. It simply draws whatever the game tells it to draw. So when the game is paused, it keeps rendering the same image over and over, frame by frame. The action on screen looks frozen, but under the hood, the rendering loop never stops. A pause menu might appear on top, but the world beneath it is still being drawn with the same care and precision as when it was moving. If you listen, the audio engine keeps running too. If it didn't, then you might hear glitches or awkward pops when you unpause. The reason AudioThread takes a different approach is to keep everything smooth. Audio buffers need to continue being processed in real time, even when gameplay has come to a standstill. While the sound effects tied to gameplay like footsteps, grunts, and clashing weapons taper off smoothly instead of cutting out, background music might shift into a softer, more ambient layer. Most modern games are constantly moving data in and out of memory, cleaning up unused objects, preloading new ones, and keeping the overall memory footprint stable. With memory management, even during a pause, these background threads keep tidying up. If they didn't, the game might start leaking memory, slowing down, or even crashing when you resumed. Pausing doesn't mean everything halts. It just means certain threads change their pace. In God of War, pausing forces the game to reconcile different ideas of time itself. There are at least 4 time systems running at once. Real time, the actual wall clock time, keeps ticking no matter what. Game time, or the in-game simulation clock, halts during a pause. UI time powers things like menu animations and button fades and usually keeps running. And physics time works in fixed intervals to maintain a consistent simulation, regardless of frame rate. When you pause, each of these threads has to adjust differently. The UI can't stop because it needs to respond to your inputs. Physics might freeze, but only after safely finishing its current step. And game time halts immediately, so enemies and characters don't move an inch. Multi-threading allows all of this to happen smoothly, but it also means that pausing is more like conducting an orchestra than pulling a plug. Every system has to be told how to behave. It's whether to stop, wait, or keep going. Each thread follows its own rules, but they all have to stay in sync. If even one part falls out of step, it can cause bugs, crashes, or weird glitches. And when you try and unpause the game, all these systems need to come back together. The physics engine picks up where it left off. Animations resume from the exact keyframe. Any input commands that were pressed during the pause are handled carefully. Sometimes, if everything doesn't align perfectly, you might see a slight hiccup or stutter. That's just the systems syncing back up in real time. From the perspective of the hardware, nothing ever paused. Your CPU is still processing logic. Your GPU is still rendering frames. The memory system is still organizing data. The fans on your console or PC might still be spinning at full speed. The scene might look frozen, but the game is still alive under the hood. Every system is doing its part to hold the moment in perfect stillness, without actually stopping time. Games don't pause, they're just good at simulating stillness. But as you'll see, even saving isn't as simple as it seems. From manual saves to invisible autosaves.